Welcome back. Thanks for getting your materials. Hopefully you have everything you need for your investigation. What I'd like to do briefly next is to just derive an expression for the acceleration of your double mass system. We will start with the mass of the first object, which is your smart cart. From our free body diagram, we know that this smart cart has a net force in the horizontal direction. That is the x-axis if we were to draw an x and y coordinate system for this object. So combining our knowledge of the net force and Newton's second law, we can say that the net force, or the sum of the forces in the x direction, is equal to the mass of this object times the acceleration in the x direction. Now let's think about our free body diagrams. What forces are acting to the left or to the right of this object? Well, we only have one force, and it's the force of tension. So we can say T is equal to mass 1 times the acceleration in the x direction, where m1 is just the mass of this object. Let's look at the second mass. We know that for this object, there's a net force happening horizontally, or there's a net force happening vertically. Combining our knowledge of the net force and Newton's second law, we can say that the sum of the forces in the vertical direction, or Fy, is equal to the mass of this object times the acceleration in the vertical direction. Thinking about your free body diagram, what forces act in the vertical direction? We have the force of gravity acting downward and the tension of the string holding it upward. And those are opposite in direction. So when you add them together, you end up getting Fg, which is positive, plus tension, which is negative. Fg minus T is equal to the mass of this object, m2, times the acceleration in the y direction. And recall what you know about Fg. This is the weight of the object. Weight is equal to the mass of the object times g. In other words, Fg can be rewritten as m2g minus t is equal to m2 times ay. So let's pause and take a moment to jot this down in your notebook. This can go in the first section if you haven't yet. Okay, so let's simplify the expression that you derive for each object. For mass 1, we have T equals m1a. And for m2, we have m2g minus t is equal to m2a. Now notice I dropped the x and y subscript here. If you think about mass 1 and mass 2, you will know that these objects are both accelerating, and since they're part of the same system, then their accelerations must be equal to each other. So in other words, ax is equal to ay, and we're just calling that a. And the cool thing about this system is that you can combine them together and add these equations together. And when you do that, tension will cancel out, and you are left with m2g is equal to mass 1 times the acceleration plus m2 times the acceleration. So how did we get this? We recognize that these two expressions explain or characterize the same system, and we can add them together to derive this new expression. All right, now here on out, it's just algebra. We are trying to find the acceleration of this system. So we can pull out a on the right. m2g is equal to a times mass 1 plus mass 2. We're trying to get a on its own. We're going to isolate this variable. We will divide both sides by m1 plus m2. And since it's in the numerator and the denominator, that can cancel. And we are left with a is equal to g times m2 all over mass 1 plus M2, which, if you notice, is the equation that is given in your notebook. All right, so that's your derivation. Today's goals include collecting a large number of data points using great lab techniques. You can enter your values here. Be smart with the cart. You only get one cart. Don't drop it like I did. And if you do, hopefully it's okay. A suggestion, maybe only vary the smart cart mass this time. I know some of you wanted to vary M2, but it might be easier with our expression to just vary M1. I'll ultimately leave that up to you. And then you'll move on to completing your formative. Thanks so much, have fun, and I look forward to hearing about your results next class. Bye.